Hi everyone, welcome back to Coding Fab. In today's lesson, we're going to explore mall customer segmentation, an unsupervised learning project that helps us group customers based on their purchasing behavior. We'll start by loading and understanding the dataset, then visualize key patterns and apply the k-means clustering algorithm. By the end of this lesson, you'll see how clustering can reveal valuable insights for better marketing strategies and personalized services. If you're new to clustering or unsupervised learning, don't worry. I'll guide you step by step and explain everything in a simple, beginner-friendly way so you can follow along with confidence. All right, let's get started. 1. Understanding the project. This project falls under the category of unsupervised learning, specifically a technique known as clustering. The main goal is to group customers into different segments based on their purchasing behavior. These segments can then be used for targeted marketing, personalized services, or deeper customer analysis. The dataset comes from Kaggle's Mall Customers dataset, which contains customer details such as age, income, and spending score. The data is in tabular format with structured rows and columns, making it ideal for algorithms like k-means. Since there are no predefined labels in this task, it is handled using unsupervised learning, where the model identifies patterns and natural groupings in the data on its own. The technique used here is k-means clustering, a popular algorithm that divides customers into k-distinct clusters based on similarity. To determine the best number of clusters, we use the elbow method. It visually identifies the point at which adding more clusters doesn't significantly improve the fit. The project is implemented using Google Colab. The main tools are Pandas for data manipulation, scikit-learn for applying k-means and computing metrics, matplotlib for visualizing clustering results and decision boundaries. And we'll follow the workflow as shown in the upper right. All right, now let's get started. 2. Data collection. Let's download the dataset into your system. In this example, we use the Kaggle Mall Customer Segmentation dataset. You can find the dataset from the dataset page on their platform and download it as a CSV file. It looks like this. You'll see the features such as customer ID, gender, age, annual income, and spending score. Let's load this dataset into your coding environment. 3. Loading the dataset. Let's read the dataset into a data frame using Pandas, same as the other tasks. Now you can see the first 5 rows. Let's take a closer look at the data in the next step. 4. Exploring the data. The goal of this step is to get a clear understanding of the dataset's structure and contents, identify any obvious issues, and gain insights through initial visualizations. First, the info method says the dataset has 200 rows and 5 columns. There are no missing values in any column. Each has 200 non-null entries. The data types are customer ID, age, annual income, and spending score are all integers. Only gender is an object type. Next, describe method says gender is a categorical column with 2 unique values. The most common is female, which appears 112 times. Customers are between 18 and 70 years old. The average age is around 38 years. Annual income ranges from 15K to 137K, with an average of 60.56K. The standard deviation is about 26.26K. Spending score ranges from 1 to 99 with an average of 50.2. This score was likely assigned by the mall based on customer behavior. Let's visually explore the distributions and relationships of the key features: age, annual income, and spending score. First, histograms with KD. Those 3 main numerical features are plotted with this code. First, create a main canvas and plot 3 subplots using a for loop. KDE True adds a kernel density estimation line to show the distribution shape. Bins 20 defines the number of bars or intervals in each histogram. From these graphs, we can see that most customers are in their 20s to 40s, peaking around age 35. The number of older customers drops off, but they are still present. The age range is wide, showing good diversity for age-based analysis. From the distribution of annual income, most customers earn between 40K and 80K annually. The distribution is right-skewed, meaning there are fewer high-income customers. The peak appears around 60K to 70K, which could be the most common income segment. From the distribution of spending score, the spending scores range across the full scale from 1 to 100, indicating diverse spending habits. The distribution is like multimodal, showing noticeable peaks around 40 to 60 and again near 80. This suggests there may be distinct groups of spenders, low, average, and high. Next, box plots. Box plots show median, quartiles, and any potential outliers. The code is almost the same as the histograms. Just replace the histplot method with the box plot method. Let's look at the graphs. There is one noticeable outlier above 130K in annual income. This means while most customers fall into a normal income range, a few have exceptionally high income. These can be treated separately or normalized depending on modeling needs. Next, pair plot. The code looks like this. This time, the pair plot method is used. Let's look at the graph. There's no strong linear relationship, but we can visually spot clusters, especially in annual income versus spending score. Largely 5 clusters. Possible groupings like high-income low spenders and low-income high spenders, and so on. This plot gives an early clue that k-means clustering will work well. 5. Cleaning the dataset. The goal is to ensure the dataset is clean and reliable for clustering by handling missing values or duplicates, and identifying and addressing outliers if necessary. As we know from the exploration step, there are no missing values. Also, there are no duplicate rows. Next, outliers. From the exploration step, annual income has one mild outlier, but since it's valid, not an error, we'll keep it for now. 6. Feature selection. The goal is to choose the most relevant features, columns, that will be used for clustering. The right features help the model group similar customers effectively. Let's use common methods. From the domain knowledge, age may affect preferences and spending. Annual income indicates purchasing power. Spending score directly shows spending behavior. And gender might be relevant if targeting marketing by gender. Customer ID is just an identifier, not meaningful. Next, let's check the correlations between features. It helps spot redundancy. If 2 features are very similar, you can drop one. But at a glance, it seems there is no strong correlation between these 3, which means each feature provides different independent information for clustering. That helps the algorithm find better separation. From the visualization result of the exploration, we saw a clear variation in distribution in age, income, and spending score, and natural clustering is visible in 2D plots. That confirms they are good candidates. So based on these results, let's use these 4 features. 7. Pre-processing. To prepare the dataset for k-means clustering by converting categorical variables to numerical form and scaling all features so they contribute equally to the clustering algorithm. First, label encoding for gender. In this case, we use label encoding with the map method. This replaces female with 0 and male with 1. This is suitable because gender is a binary categorical variable, and mapping keeps the result clean and compact with just one column. Next, feature scaling. Since k-means clustering relies on Euclidean distance, it's important that all features are on the same scale. Without scaling, a feature like annual income, ranging from 15 to 137, could dominate others like gender, just 0 or 1. Let's use standard scaler to standardize the features so they have a mean of 0 and a standard deviation of 1. Now all features are normalized, making the clustering fair and balanced. Let's move on to the modeling step. 8. Modeling. To apply the k-means algorithm to the pre-processed customer data and group similar customers into distinct clusters based on their behavior and characteristics. But before we run k-means, we need to decide on the number of clusters k. There are several ways to decide the number of clusters k, such as elbow method and the silhouette score. Let's try the elbow method. It runs k-means for a range of k values like 1 to 10. Then calculate the inertia for each k. Inertia is the sum of squared distances from each point to its assigned cluster center. After that, plot inertia versus k. Then look for the elbow point. This is the result. The curve drops sharply from 1 to 4, then begins to flatten around 5. It may be a bit difficult to find, but we can see a change in angle around number 5. From 5 onwards, the gain in clustering performance becomes smaller and smaller. So this point where the curve bends or elbows represents the optimal number of clusters. So according to the elbow method, the optimal number of clusters is likely 5. This is where the rate of decrease in inertia slows down, meaning that adding more clusters beyond this point gives diminishing returns in clustering performance. Therefore, we will proceed with K5 for the k-means clustering model. Let's group customers into 5 distinct clusters based on their age, income, spending behavior, and gender. This code fits the k-means model to the scaled data. Assigns each customer to one of the 5 clusters. Also, a new column cluster is added to the data frame, representing each customer's cluster assignment. Now let's check the data table, and each customer is labeled as belonging to cluster 0, 1, 2, 3, or 4. We can analyze or visualize each group to understand the shared characteristics within them. Nine, evaluation. The goal is to understand and interpret the clusters created by k-means by visualizing them in 2D space and analyzing the customer characteristics in each group. Let's plot annual income versus spending score colored by cluster. We can use a scatter plot. Please adjust the palette, marker size, and transparency as you like. As you can see, the clustering has effectively segmented customers into 5 meaningful groups. There are clear distinctions, especially between those who have high income but spend differently and those with low income who spend actively. This information can be used to tailor marketing strategies, product recommendations, or loyalty programs for each customer segment. Ten, labeling. The goal is to analyze each cluster and give it a descriptive label based on customer behavior. This helps businesses easily understand and act on the segmentation. Let's check the cluster averages per cluster using the group by method. This helps identify patterns like, are they young or older? Do they earn a lot or a little? Are they high or low spenders? What's the gender ratio? Okay, let's check each cluster. First, cluster 0. This group is the oldest on average, 56 years old, with low income, around 46K, and moderate to low spending. Gender is balanced, about 49% male, so they can be labeled as careful budgeters. Next, cluster 1. These are high-income earners, around 85K, with very low spending scores, around 14. All are male, so they can be labeled as wealthy minimalists. Next, cluster 2. This group is young, around 29, earns a moderate income, around 61K, and has a very high spending score, around 70. All are male. so they can be labeled as active shoppers. Next, cluster 3. These customers are mid-aged, around 38, have higher income, around 82K, and above average spending, around 54. All are female, so they can be labeled as premium customers with a female skew. Lastly, cluster 4. This group is the youngest, around 27, earns the lowest income, around 39K, but has a high spending score, around 56. All are female, so they can be labeled as young impulsive spenders. This is the summary table. Let's imagine labeled users. Cluster 0 is a careful budgeter, like a housewife in her 50s or 60s who carefully manages household expenses. She compares prices, uses coupons, and only shops when there's a sale. Practical, steady, and avoids impulse buys. Cluster 1 is wealthy minimalist, like a successful male executive who earns a lot but lives simply. He buys high-quality essentials and avoids flashy or trendy items. Doesn't shop often, only when necessary, and prefers quiet premium brands. Cluster 2 is active shoppers, like a young man in his 20s working in tech or media who loves sneakers, gaming gear, and online shopping. He spends freely on what he enjoys, fashion gadgets, and social experiences. Cluster 3 is premium customers, like a professional woman in her 30s or 40s who loves luxury skincare, stylish outfits, and nice restaurants. She has a good income and invests in quality and comfort. Loyal to trusted high-end brands. Cluster 4 is young impulsive spenders, like a university student or young office worker, very active on Instagram, always shopping online for the latest fashion or beauty products. She loves trying trends and reacts quickly to influencer promotions or sales. This is a simple example. Try creating your own clusters and analyzing them, then let's create your own customer personas. So that's it for this customer segmentation. After evaluating the clustering results, we assign descriptive labels to each group based on average income, spending behavior, age, and gender. These segments help us better understand our customers and make informed decisions for targeted marketing, promotions, or service customization. And that's it for today's lesson on this topic. We explored how to group mall customers based on their purchasing behavior using the K-means clustering algorithm. We walked through loading and understanding the dataset, visualizing patterns, applying clustering, and evaluating the optimal number of groups with the elbow method. This lesson showed how unsupervised learning can uncover meaningful insights for better marketing decisions and personalized strategies. Customer segmentation is a powerful technique used by businesses everywhere, and now you've seen how to build it step by step. Keep practicing with different data sets, experiment with various clustering methods, and see how these techniques can be applied to real-world business scenarios. The more you explore, the deeper your understanding will grow, and you'll gain the confidence to tackle even bigger projects. Okay, thanks for watching today's lesson on coding Fab. I hope you found these tips useful and feel more confident. Remember, practice makes perfect, so try using these tips in your project. If you enjoyed this video, don't forget to give it a thumbs up, share it with your friends, and subscribe for more Fab coding lessons. Until next time, keep practicing and stay Fab.